Okay, so in the last video we have discussed about kinetic energy of the mass spring system. In today's video we are going to drive the formula for finding the potential energy of the mass spring system, right? So we are going to start with the average force, right? Now we know that how we can find the average of anything, right? We need to add those two things together, and we need to divide that by the total number of it, right? So initially what we are going to do today is we are going to write the formula for the potential energy. So which means we are gonna discuss, wait for it. Okay, so we are going to discuss about potential energy today. Potential energy. Initially, average force acting on a body. Average force, what is average force acting on a body? So average force acting on a body. What is the average force acting on a body? FAVG, which is average, is equal to F1 plus F2 over 2. We need to add those two quantities together and we need to divide that by the total number. So here we have two total forces, that's why we have to divide this with the 2, right? Now see, we have initial first force is 0. So F average is equal to 0, and second force we have kx, right? We have kx over 2. Now see, this 0 has no value here, so F average is came out to be kx over 2, right? Now what is the potential energy? We know that potential energy is stored in the body by the work, right? Work done on a body is stored as potential energy. So work done on the body is what? Work done on the body is what? Work done in the body is, wait, W is equal to F dot D, but here F average, right? Since we have found F average dot X. Okay, so what is F average? That is of course kx over 2 into x. So x into x is what? K over 2 x square. This is the work done. This is the work done on the body stored as potential energy. This is what? Wait for it. This is work done on the body stored as potential energy. Stored as potential energy, right? So which means potential energy is equals to what? Potential energy is work done, right? So 1 over 2 kx square. So we have now got our potential energy of the mass spring system 2. The kinetic energy of the mass spring system was 1 over 2 k x naught square minus x square, and the potential energy of the mass spring system is 1 over 2 k x square. Right now we need to know where we're going to have our maximum potential energy and where we're going to have our minimum potential energy. See, what is potential energy? Potential energy is due to the is due to what? Is due to its position, right? In actual, it is work done against the field. It is work done against the field. But here we are going to take an example, or take this potential energy as due to its position, right? So it will gonna be maximum when it will cover some displacement, which means at extreme position it will be maximum. Extreme position, maximum. Since at extreme position it will have some displacement, and potential energy is actually due to uh, the position of the body, right? So when it will be on its extreme position, it will have some maximum displacement. That's why we're gonna have potential energy maximum at extreme position. And where we're gonna have our minimum potential energy? We're gonna have our minimum potential energy, minimum potential energy at mean position. Since it will not have covered some displacement, that's why we have minimum potential energy, mean position, right? Now see what we have done today. We have derived the formula for finding the potential energy of the mass spring system, and before that we found the formula for finding the kinetic energy of the mass spring system. How we started with deriving the formula for potential energy of the mass spring system? We initially took a concept of the average force, right? What is average force? Equals to F1 plus F2 over 2, and we know that F1 is 0 and F2 is kx over 2. Kx over 2 is actually the average force. Now work done by the average force is what? Work done is equal to F average force into x, right? X is the displacement. Now work done is equal to F average is kx over 2 into x. X into x is x square. That's why work is equal to k over 2 x square. Now see, this is work done on the body stored as potential energy. So our potential energy also equals to 1 over 2 k x square. Our maximum potential energy would be at extreme position. Since at extreme position body will have covered some displacement, and potential energy is due to the position of the body, right? If a body will gonna cover some displacement, it will gonna possess potential energy, otherwise it will not, right? So at mean position our potential energy would be minimum. So this was all for today. We have completed the potential energy too today. In the next video we're going to have the formula for finding the total energy of the mass spring system, or total energy of the motion under elastic restoring force. We're going to have that concept there, and we're going to summarize everything, right? Summarized the energy concept there, where we're going to have maximum kinetic energy, maximum potential energy, minimum kinetic energy, and minimum potential energy. So this was all for today.